Hello, my name is John Capobianco, and today I'm going to be talking about agentic AI agents, specifically ReAct agents, reasoning and action. So, you may have started to hear about agents. I'm going to show some articles that are just coming out. This is a new horizon, a new evolution beyond generative AI. Now, there have been great approaches like retrieval augmented generation, RAG, and other forms of RAG, graph RAG, and raptor trees. Agents are slightly different. We don't need a vector store. We don't need to write like a pipeline. What we can do in Python in particular is make functions that turn into tools that the AI or the LLM has access to invoke. So I can write a little function in Python, say a calculation function, and ask a question of the AI, and if the AI determines that invoking that tool, running that little bit of code, will help answer the question, it will go ahead and run the code. It's much more than that. It's a little bit difficult to explain, but you'll see it in action. The other thing is that it can do it recursively. I actually struggled a little bit to get it to come to a final answer. And it's all through prompts. There's very, very little code involved here. And the code that we do need to write is simple. So don't be scared of this just because it's called agentic AI or we're making agents equals complexity or confusion or difficulty. It's actually very, very easy. It actually turns out to be the opposite. So it's primarily driven through your prompts, and we can tie this into network automation. Of course we can. That's why I'm making this video. So, can I talk to a Cisco device using an LLM as an intermediary that takes my human language and runs tools and responds with human language? Now those tools, in my case, are going to be Cisco pyATS. So I'm going to write a little bit of Python code as a function that's pyATS code that's going to parse certain commands and return JavaScript object notation. So let's get started with ReAct agents for network automation. Now, if you do a quick Google search for agentic AI and then click on the news, you're going to see all kinds of articles. The future of automation, revolutionizing business processes, the next big breakthrough. AI isn't magic, but it can be agentic, from the New York Times. Why agents are the next frontier. You get the idea. All these great articles about agentic AI. So we're going to look at an agent process or approach known as ReAct. Okay? Now this is reasoning, the re part, and acting, the act part. Now it makes a delineation of reason only, chain of thought using language models, and also actions with observations as acting only, things like WebGPT. Can we combine the reasoning in the language model to perform actions to drive observations? Combining reasoning and acting into ReAct. Now there's some great stuff here. There's the white paper that you might want to read. There is a blog post about this approach that you might want to read. And there's also some great imagery like this, where with our ReAct agent, we're going to have our question from the user prompt, which is going to lead to thoughts, which drive actions, which lead to observations. Now this can happen iteratively, and I actually struggled a little bit because it kept iterating even after I'd found the correct answer in some of my early attempts at this. Ultimately, it should drive to a final answer. Now in LangChain, if anyone's familiar with LangChain, it does have some React agent approaches and some agent executors and an example here with chat history. So if anyone who wants to get started with React agents, you can look it up in LangChain to get going, and that's what I'm going to be using today. So the first thing I'm going to do is get Ollama running because I want to do this free and privately. So we have our Ollama server up, and I'm going to Ollama list just to show you that I'm going to be using the Llama 3.1 model, which is probably the best performing model that I've found so far. Now, in terms of the agent, first thing before we start talking about agents, I want to talk to the Cisco DevNet Always On Sandbox router. So this is the URL and the credentials that I've saved into a testbed file. This is YAML code, not code, but YAML is the format here for pyATS testbeds. Now I can load that file from my Python agent to help set up pyATS code. So this might look a little familiar to some of you. Let's look at show IP interface brief. I'm going to load the testbed. I'm going to pick my device from the testbed, .connect to the device, .parse the show IP interface brief command, .disconnect, and return that parsed output from the show IP interface brief command. Okay, just a little function. And I have the same for IP route and the same for access list. You can see that I've only imported a handful of libraries here, the pyATS topology loader, and then the agents prompts from LangChain, and from LangChain community, the Ollama. Also some core tools. The next thing I do is define with the decorator here is the tools. Now there's a dummy string of input because I'm not technically sending any action input. I'm sort of hard coding the action here. But there is an opportunity to pass along information in the form of action input, and I'll show you that later. But this tool returns that show IP interface brief function, okay? So I've decorated some tools. I set up my LLM as Ollama with Llama 3.1, and then I create a list of tools. And I have this list of tools for those 3 tools that I have so far. I'm going to render text descriptions for the tools for inclusion in the prompt. So the text description, render text description for tools. And here is a template. Now the template is very important. And also, I've taken some of this boilerplate information from a React Google or a GitHub repository. React template GitHub. I believe it's, hang on. It might take me a second to find this. I just looked at it yesterday. But there's some React boilerplate code that you can find online that gives you a starter template that works well. So I'm not going to read all of this, but these are my instructions where I have my thought. And my thought for this agent is, do I need to use a tool to answer this question? Yes. Action, the action to take, should be one of, and then I pass it the list of tools that I have from that array of tools we set up. Action input, I just say the input to the action and it will be ignored by the tool. We do need to include action input. In this case, I'm overriding it with hard-coded stuff. I may adjust this, and I'll talk about that later in the video. Now, the observation is the result of the action. And when you have a response to say to the human, or you do not need to use the tool, you must use the format Thought, do I need to use a tool? No. Action, display your response. So when you don't need a tool, it means you know the answer. Go ahead and display the answer. A little bit on tool selection. A couple of examples here just to show it. If I don't need to use a tool, give the final answer of the loopback IP address. I walk through an example. Avoid repetition. Correct formatting is essential. Handling errors or invalid tool usage. Now the tools, the assistant has access to the following tools. Tools, begin, and the previous conversation is the chat history, and the new input comes from the input down here below. Input. Now it does have a scratch pad for the agent. We don't do anything with that other than initialize an empty scratch pad. And we're also going to initialize an empty chat history. So this is when we're going to invoke. We're going to use some of these functions from the template. So we have some input variables, the input tools, tool names, agent scratch pad, and chat history. Our prompt template is our template, our input variables, and some partial variables, which is just the tools and the descriptions joined. Okay? We're going to create the agent now. So from here down, we have an agent. We're going to create the React agent with the LLM, Olama Llama 3.1, the list of tools, and the prompt template. We're going to use the agent executor and execute our agent with our tools, handle some parsing errors, do it with verbosity. And in my case, I'm going to use JSON as the format, since that's the format that we're expecting from pyATS. We can have an input question here, and I'm going to say, what are the names of my access lists? Let's change this. Let's start with something to do with interfaces. Actually, you know what? This is fine. This is a perfect example. So we'll use this one, hoping that it invokes the show access lists tool, right, when we ask this question. So then we're going to save the response so that we can extract the output of the final answer. So we can print the user question and the final answer at the very end of this. But here's where we're invoking this agent executor with our input and some blank starter history and scratchpad. So the whole idea here is that we can just ask it these questions. Now I'm going to adjust this code. This is very early in the development. I'll probably wrap this in a Streamlit app where we can chat with it through a web interface and display the information in a web interface. I'll do an updated video when I get the Streamlit overlay working. For now, I'm just working on tool expansion, but I'll show you what I mean by that. Okay, so I need to activate the virtual environment that I've set up for this. And this has primarily the LangChain libraries. I haven't needed to import too many crazy things. So I have pyATS in here and yeah, all the pyATS stuff and the LangChain libraries. So let's go back into that agent testing folder. Now, let's just run something that doesn't invoke the tools. Let's just say, why is the sky blue? How about that? Now, what I'm hoping for is that it's going to say, no, I don't need to invoke the tool or any of my tools to answer this question. And here is the answer, and it finishes the chain. Right, so we go into an executor chain, LangChain, and we finish the chain. Here is the question, here is the final answer. All right, now let's try to invoke some of the tools. And what we'll start with is show IP interface brief. Right, and we're going to say, are all of my interfaces up? Are all of my interfaces up? Now it's going to say, yes, I need to use a tool, and we're going to pick the show interface tool. Now this is going to have all of the up-down information, and it looks like all of the interfaces are up, so it should come back and say yes, or it just says all of my interfaces are up. So they are all up, right? And it has a follow-up thought here. Do I need to use a tool? No. And here is my final answer. So let's ask it something about an IP address. Let's say, what is gigabit Ethernet 1 IP address? And we know it's 10.10.20.48. So we can literally chat with this router using the agents by mapping pyATS commands. And here's the JSON payload. And, right, we use the LLM to parse it and give us the human answer. So we can do things with routing tables as well. Let's ask it, what is the default route? Let's go ahead and run the code. And it's going to, yes, I need a tool. Use the show IP route tool. And it's going to grab the routing table here. Now the default route is actually 10.10.22.54 using gigabit 1. And we can use, so default route is all zeros, next hop 10.10.22.54 on gigabit 1. So we could ask it something like, well, what are the other routing questions? How about something like this? Pretty neat, right? If I was a packet going to 10.111.111.111, what interface would I use? And let's see if it knows that it's loopback 101 as the interface to use if it was going to that IP address. Oh, I have one too many ones. One too many ones. Try it again. Sorry about that. And then let's do an access control list one. And then let's add one. Let's add one. Let's add a new tool. So it's actually trying show IP interface brief. Instead of show IP route. And I guess it'll pick up the IP address here. You would use the loopback 101 interface. So it didn't pick the routing tool, it picked the show IP interface brief tool, but still had the correct information. Interesting. So, what are my access lists names? And what can you tell me about them? So this one should know it needs to use a tool, pick the access list tool. Now it should run the show access list command, and we should get this back as JSON. And there's a couple in here. There is NAT ACL test Meraki SL defined access list. So there's the names. But it didn't tell me, what can you tell me about them? Failed, sort of. But it did give me at least the correct names. So this is working out pretty well. Okay, so let's add a new function, a new tool to our agent to show you how easy it is. Also, I want to really explore and really highlight the difference here with and without a tool. So where's my tool list here? I have a list of tools. I'm not going to change the template. So here are my tool lists. Now there's nothing in here that can give us the show version. So let's adjust the code here from, do you have any interfaces that have input errors? Let's try what version am I running? And we're going to run this code. Now, I expect word salad, and I expect to say, yes, I need a tool to answer this, but none of these tools are sufficient to get the version answer. So let's see what it tries here. It's going to try show IP interface brief, and it may try a few different tools until it exhausts its capability and then self-understands that the information provided does not have the show version information available to it. So you can see here, it tried a tool. System version is not directly related to interface status, and it tries its best. So let's address this, and we're going to just copy the show access list function here, and we can go over it after I copy and paste it. So we're going to load the test bed, and this one here is going to be show version. Now, I love pyATS. Test bed, load the test bed. The device we need is CAT 8000V. We're going to connect the device, and then we're going to parse, and let me change this show access list here to version a few times. So now we're going to parse the show version command, disconnect from the device, and then return. I just call it running config. That's probably a mistake. I should update it to show version or something. It doesn't matter. It's just a variable name. So now we need to make a tool. So we're going to copy our tool here and change this to show version tool. Show version command. And that's it. That's all we need to do aside from add it to our tool list here. Show version tool, which will run the show version tool, which will invoke the function, which will get the JSON and augment the prompt to answer the question. It's the only thing I've changed here so far. So let's try it again. And let's see if it picks the show version. It does. Right away, it knows through the reasoning and action. The reasoning, do I need to use a tool? Yes, I do. Let's pick the show version tool now that it's available to me. Get the version information. Oh, I've made a mistake. Aha. I'm going to fix it. I'm not going to edit this out. I've made a mistake. I've missed one thing in the tool. Instead of show access list, I should be calling show version. Excuse me. Let's try this again. I am not perfect. And here we go. So it's running the show version command, and we're going to get a JSON payload back of the show version, and the AI should be able to answer the question, what version am I running? And it has a system image of boot flash. So that's not great. So that says the system image, but that's not right. So let's try this again. Let's just adjust the question slightly. What Cisco iOS XE version am I running? That could be maybe a little more helpful with the prompt and to nudge the agent in the right direction as to what key pair values in the JSON payload to pick. Let's just try it again. Now, I'm going to rename this GitHub repository and post this. The link to the GitHub will be in the YouTube comments. There we go, much better. The Cisco iOS XE version is 17.12.02, and we are running 17.12.02. Now, I might be able to ask other questions, and that's pretty powerful. We've explored agents and agentic AI using a ReAct system. In total, it's 250 lines of code. Most of that is the template. So how many lines of code is the template? It's over 50 lines of code. So it really is not a lot of code to get going with agents. Now, the other thing that is glaring and maybe obvious is that instead of dedicated tools, since we do have this idea in the template of what to pass along, the input, where did it go? The input, action input, we may be able to boil this down to a single tool that we pass the show command into, and just have one tool that is pyATS to run the show command and parse it. My problem when I tried that is that it wants to add pipes and filters and modify the show command that you may do at the CLI, but from a parsing perspective, it breaks the parsing. So for now, I'm going to leave it as dedicated tools. So let's talk to some conclusions. Okay, artificial intelligence has moved very fast. I've been doing it since November of 2022 with ChatGPT 3.5, just using the GUI to start exploring AI. I moved into API access, and then I moved into retrieval augmented generation, raptor trees, GraphRag. I moved into plugins for ChatGPT. I've explored a variety of tools, and I don't think there's anything as exciting as an agentic AI approach, where we build an agent and give it access to tools, and those tools can act on their own. And those tools are often represented as Python functions. So it's really easy to reuse code. If you have some killer network automation function in Python, you can wrap it around an agent and give an agent access to that Python code. So at a high level, think of it that way. Right now, you write Python code and give humans access to the code. Run this Python script and it will do a certain thing. And it's made up of certain classes and functions. Now, with agentic approaches, we can write Python code and give AI and LLM access to run that code to fulfill its needs. Now, you've seen me say, why is the sky blue? It doesn't need a tool. It has that baked into the core model. What version am I running for Cisco IOS XE? I need to invoke a tool. The tool should get the JSON, which can augment my original prompt to help the LLM give me the best answer. So, we are moving into a world of agentic AI. It is coming. And the world of possibilities are endless here. I could literally map every parser if I had the time, or maybe with AI's help. I could say, here are all of the show commands that iOS XE supports for parsers. Please write equivalent function and tools. And now this agent can parse any show command and have the reasoning from ReAct to pick the right show command from a library of hundreds or thousands of parsers, and then act upon that by executing and getting the JSON and showing the user the answer to their question. So I'm just getting started. I'm going to make this open source. Please add parsers if you want. Show license, show environment, show CDP, LLDP, BGP, OSPF. Now I'm using a DevNet sandbox, so I'm a little bit limited in the show commands that I can run, but we've explored 3 that I built before the session today, and we added show version in 30 seconds. Define the tool, give it a decorator, add it to your list, your array of tools that the agent has access to, and boom, we've added a new tool. So please reach out to me if you have any questions about this. Please try to get started with this. Please clone and fork my repo. I will accept pull requests, and I hope to maybe see you someday and hear that this has inspired you to start building AI agents. All right, talk to you soon.